Good morning, children. In the previous class, you have studied about polygenic inheritance. Today, let us study the mechanism of sex determination. How sex is being determined in different organisms. This mechanism was first initiated by a scientist Hen King. It was first reported by a scientist Hen King. He was studying about the process of spermatogenesis in an insect, namely wasp. You know very well that spermatogenesis is the process of formation of sperm from spermatogonium. When he was studying this process, he could find a special type of nuclear structure throughout the process. But after the formation of sperm, half of the sperm received this structure, but the other half did not. And he called this special nuclear structure as X body. Now we are calling this as X chromosome. Is it clear? The study was started by a scientist Hen King. He studied the process of spermatogenesis. Throughout the process of spermatogenesis, he could find a special type of nuclear structure. But once the sperms are produced, 50% of the sperms are having this nuclear structure, other 50% did not. He called this special structure as X body. At present, we are calling it as X chromosome. So, first let us study the sex determination mechanism seen in case of human beings. The total number of chromosomes present in human being is of 23 pairs. First 22 pairs are called autosome and the last one pair is called the sex chromosome. Clear? So, in case of a male, the 23rd pair consists of X and Y chromosome. But in female, the 23rd pair has XX chromosome. So, male is heterogametic, female is of homogametic. So, during gamete formation, 50% sperms receive X chromosome and the other 50% receive Y chromosome, because male is heterogametic but female is homogametic. So, all the X invariably consists of only X chromosome. Now, during fertilization, when the X carrying sperm fertilize the egg, the resultant will be female, whereas Y carrying sperm fertilize the egg, the resultant will be a male child. So, who is determining the sex? Male is determining the sex. But normally in the society, when a female give birth to a girl baby, the society blame the female for giving birth to a female child. But in human population, sex is determined by male and male is a heterogametic. 50% sperm consists of X chromosome, other 50% consists of Y chromosome, and female is a homogametic. All the X invariably has only X chromosome. So, when the sperm carrying X chromosome fertilize the egg, the resultant will be female. Y carrying sperm fertilize the egg, the resultant will be a male child. So, male determines the sex in human beings. Now, let us take the mechanism in case of insect like grasshopper. So, if you take insect like grasshopper, here what is happening? The male insect is again heterogametic and female is of homogametic. In case of male insects, 50% sperm consists of X chromosome, other 50% did not have X chromosome. So the pattern is called the XO system. But female insect, homogametic, all are having X chromosome. Female insects consist of 2 X chromosome. So the egg consists of only 1 X chromosome. So can you see here? Here female is having double X chromosome. Male is having XO pattern. So if you are seeing the male insects are having 1 chromosome less than the female. So all the eggs are having which chromosome? Single X chromosome, because gamete is a haploid. But in case of male, 50% sperm consists of X chromosome and the other 50% is not having X chromosome. So here what is happening? When in case of insects, the sex is determined by male. When a sperm carrying X chromosome fertilize the egg, the resultant will be of female insect. But the sperm not having X chromosome fertilize the egg, it will develop into a male insect. So in case of insects also, sex is determined by male. But here an exceptional case is of Drosophila, where you have come across Morgan used fruit fly or Drosophila melanogaster for his experiment. But in Drosophila, it follows a human pattern. Male insects have XY sex chromosome and female has XX type of sex chromosome. So in Drosophila, male is determining the sex just like human population. But in other insect, the system is called the XO system of sex determination. Now next one is about let us pass on to the mechanism of sex determination in birds. In case of birds, we can say female heterogamety is seen. The sex chromosome present in female birds is of ZW, and in male birds, male are homogametic, they have Z chromosome. So in case of birds or fowls, female heterogamety is seen. Female is having ZW chromosome, male is having ZZ chromosome. Male is of homogametic. So all the sperm consists of only Z chromosome, but 50% eggs are having Z chromosome and other 50% is having W chromosome. So when the sperm fertilize the egg having Z chromosome, the resultant will be a male bird, whereas the sperm having Z chromosome fertilize the egg having W chromosome, the resultant will be a female bird. So female heterogamety is seen in birds. In birds, sex is always determined by the female and never by the male. An interesting phenomena you can see in case of honeybees. Honeybees are exceptional cases just like Drosophila. In case of honeybees, they have 2n number is of 32. Diploid number they have 32. Okay, 32 they are diploid number. 2n number is of 32. And always gametes are haploid, so n is equal to 16. So let us take in case of female honeybee, they are diploid, 2n number 32 chromosome. Male is of haploid, n is equal to 16 chromosome. Now during gamete formation, the egg mother cell having 32 chromosome will undergo meiosis. Meiosis is reduction, division. So after meiosis, the egg is formed it consists of 16 chromosomes. Clear? But male is already haploid, so the sperm mother cell will undergo mitosis and it is equational division. So the sperm consists of N is equal to 16 chromosome. This is clear. In case of honeybees, female is diploid, male is a haploid. Female 2n number is equal to 32, male n is equal to 16 chromosome. The egg mother cell is having 32 chromosome will undergo meiosis. It is reduction division. After that it produces the egg. Egg is a haploid. It is having 16 chromosome. But male insect already haploid. So sperm mother cell is a haploid. It is undergoing mitotic division or equational division and produce the sperm. That is N is equal to 16 chromosome. During fertilization, the egg combines with the male gamete and form the female honeybee. That is 2n32. But sometime what is happening? Some of the egg cell, the female gamete, without fertilization forms the male insect. So in case of honeybee, the male bee is formed without fertilization. You have already studied if a male gamete directly form a new organism. If the female gamete directly form the new organism without fertilization, the phenomenon is called parthenogenesis. So male honeybees are formed by parthenogenesis, but the female honeybee is formed by means of fertilization. Is it clear? In honeybee, female is diploid, 2n has 32 chromosome, male is a haploid, n is equal to 16 chromosome. Egg mother cell is diploid, undergoing meiosis or reduction division and form the egg, n is equal to 16 chromosome. As the male is a haploid, by mitosis sperms are produced, male gametes are produced, n is equal to 16. When male and female gamete combined with each other by fertilization, that results in the formation of female honeybee. But the female gamete without fertilization directly form the male honeybee. The process is called as parthenogenesis. So today you have studied the mechanism of sex determination in case of insects, honeybee, human being, Drosophila, as well as in birds. Go through it. If you have any doubt, you can clarify it. Thank you, children.